Well, good morning, everyone. My name is Dr. Monks, and on behalf of the Southwest Center for Pediatric Environmental Health, I want to thank you for joining us today. The Southwest Center for Pediatric Environmental Health is one of 10 pediatric environmental health specialty units, also known as PACUs in the United States. The purpose of the PACU program is to serve as a leading national source of medical information and consultative advice on environmental conditions that influence human health through reproduction and pediatric development. The PACUs are here to serve health professionals and community members alike on environmental health issues that impact pediatric development. To serve part of our mission, we are offering a Pediatric Environmental Health Grand Round series once a month on the third Thursday of each month. We are grateful that today Dr. Christina Sobin has joined us to discuss the issue of lead exposure in U.S. children. Before we move forward, I want to talk to you a little bit about some housekeeping items. You will all be muted today and you will not be able to share your video. However, if you would like to ask a question, we do ask that you place that question in the chat box to the right of your screen. We will have Miss Moraima monitoring that box today, and she will make Dr. Sobin aware of your question throughout the presentation and at the end of the presentation. We would also like to bring your attention to the fact that the American Academy of Pediatrics, the Agency for Toxic Substances and Disease Registry, as well as the EPA, have all provided support for the work of the PACU and programs such as this to exist. We are aware that many of you will be requesting CME and CNE credits for today. And so if you have any questions, we ask that you contact Ms. Moraima Baron at the end of the presentation, and she can help you with those requests. We do, however, ask that if you will be asking for CNE or CME, that you stay through the duration of the program. Our next grand rounds will be on April 21st at 11 a.m. Mountain Time. We will be hearing on pediatric and adolescent substance use disorders. Dr. Lindsay Redderith is an emergency medicine and pediatric addiction medicine fellow, and she will be speaking to us on that day. So without further ado, the Southwest Center for Pediatric Environmental Health, the EPA Region 6 Pediatric Environmental Health Specialty Unit, is pleased to be joined by Dr. Christina Sobin. Dr. Sobin was trained as a clinical psychologist at the New York University in New York City. She completed her postdoctorate program training in cognitive neuroscience at Columbia Presbyterian New York State Psychiatric Institute, and while at the Rockefeller University in New York City, and had a NIH National Institute of Child Health and Human Development K Award to study children at high risk for neurocognitive and psychiatric disorder due to genetic deletion syndrome. She was a research scientist in New York City until 2006, at which point she took a faculty position at the University of Texas at El Paso. For the past 15 years, Dr. Sobin has conducted an interdisciplinary program of research investigating mechanisms, sources, and solutions for ongoing problems of childhood lead exposure in high-risk neighborhoods. Dr. Sobin joined the Developmental Neurotoxicological Society in 2013 and since has served as the membership officer on the Publications Committee and as secretary from 2018 to 2020. Again, we are very fortunate to have Dr. Sobin with us today, and on behalf of the Southwest Center for Pediatric Environmental Health, we would like to offer her a warm welcome. Thank you, Dr. Sobin.
Thank you very much. much, Dr. Monks. Good morning, everyone. Thank you so much for joining in on this this morning. The talk, as you know, is going to be discussing the problem of child lead exposure in the U.S. and specifically our need to reliably detect dangerous lower level lead exposure in highest risk children. And here by lower level lead exposure, I'm referring to child blood lead levels below about 7 micrograms per deciliter and as low as 2 micrograms per deciliter. So I'll be explaining strategies that our lab has developed that can greatly improve our detection of children with these lowest levels of lead exposure and thus can increase the numbers of families that we're able to reach for low-cost parent-initiated mitigation of home lead hazards. So when I was working on this talk, I developed it for professionals with prior knowledge regarding common child lead hazard sources and the dangers to children of exposure to any level of environmental lead, from lowest detectable levels to higher levels. So for those of you listening today that may not be that knowledgeable about child lead hazard sources or the extensive literature showing that any level of lead is damaging to children's development, you can find great information on the websites of the CDC, the EPA, and also the U.S. Department of Housing and Urban Development, HUD. They will have extensive reference lists, and I'll be showing you some references in the talk today. So I always like to show this slide at the start of a talk rather than at the end when I have everybody's full attention. The work that I'm going to be describing today does not get done without the dedication and contributions of many, many dedicated people. Over the past 15 years, over 50 UTEP students have participated in the work that I'm going to be talking about today. And I just want to take a minute to acknowledge our most recent pre-pandemic research team, many of whom have now graduated and have moved on to other places. So I amended this slide a little bit so that you could see the name of the student, but also where they currently are, because as you know, the pandemic caused a lot of disruption, and also during the pandemic, many people graduated. People that worked on this project up until the pandemic stopped us: Michelle Del Rio, Jalene Avila, Alexander Obeng, Crystal Costa, Christina Rodriguez, Diana Moreno, Angela Mendez Contreras, who's still at UTEP, and Chandi Magadara, who is still working on her doctorate at Kansas State University. Also, I want to acknowledge our funders. Most recently, this has been the U.S. Department of Housing and Urban Development, and also the U.S. EPA, NIH, and the Rockefeller University in New York City, as well as an endowment from the Edward J. and Helen M.C. Stern Fund at UTEP. So the talk is divided into 6 sections, and I'm going to start by showing you the model that our lab has been developing over the past 15 years, which is a school-based neighborhood approach for monitoring children for lead exposure. And then we're going to take a step back and we're going to consider, why is it that lead exposure is still a problem in U.S. children and what's the evidence for that? And then we're going to think about what might be sustaining this problem, and in particular, how our current practices are not aligned with our current knowledge. We'll take a few minutes to briefly talk about advances in policy research that suggest that changes in practice necessarily have to precede changes in policy. And then we'll get into the details of the approach that we're recommending and how we can better align our current practice with knowledge. So to start out, this is the model that we're going to be providing the rationale for today. This is an interdisciplinary neighborhood-based approach for monitoring child lead exposure. As many of you probably know, currently in the U.S. today, we miss the detection of hundreds of thousands of lead-exposed children, and we miss our opportunities to provide education and low-cost home mitigation for parents to protect their children from lead exposure. So I'm going to be focusing today on the rationale for this new interdisciplinary model. As I said, it's guided by current knowledge in several ways, and it differs radically from current practice. At the core of this approach is an interdisciplinary team of experts that oversee everything that happens at each stage. So the model includes three main components. First of all, annual routine child blood level monitoring in the public schools or in trusted neighborhood settings such as YMCAs or recreation centers, with rapid dissemination of results to parents coupled with education. And the second component is home screening and mitigation offered to parents based on real-time child blood levels. And the third critical component is community-level organization, including review of GIS-mapped results, tracking of emerging trends with aggregated data, and ongoing transfer of relevant knowledge. So let's go over the background that supports this model. As this chart shows, our understanding of what constitutes a dangerous level of lead exposure in children has changed dramatically in a relatively short amount of time. Interestingly, the problem of human lead exposure has been traced back as far as Neanderthal times. This is because lead exists in the Earth's crust, and as metals go, lead is very, very soft and it has a very low melting point, making it easy to shape tools and objects. In fact, lead can be smelted over a simple wood fire. But unlike other metals, such as copper or zinc or iron, lead does not exist naturally in the human body, which is probably one of the reasons why lead can have such damaging effects in children, even at lowest levels of exposure. Another characteristic of lead I don't have time to talk about today, but it's a very, very important aspect of lead, is that it's a calcium mimic. And we suspect that the fact that lead can replace calcium in many critical receptors throughout the body also is a reason why it becomes so very damaging, even at lowest levels of exposure. So as shown here on this slide, during the 1960s and 1970s and into the 1990s, changes in policy, laws, and guidance regarding environmental lead produced a remarkable reduction in the numbers of children with higher levels of lead exposure. However, unlike the problem of higher levels of child lead exposure in the 60s and 70s, the child public health problem that we face today is a very different and much more challenging problem, because today we're faced with eliminating child exposure to dangerous lower levels of environmental lead. That is, lead in the environment that produce dangerous child blood levels well below 5 micrograms per deciliter. Over the past 60 years, over 100 child clinical studies have been published that demonstrate the very damaging effects of chronic exposure to lower level lead during development. And it's now broadly accepted that no level of lead exposure is safe for children. So for those of you interested in reading more into this literature, this slide is showing the names of some earlier leaders in the characterization of child lead exposure: Philip Landrigan, Herbert Needleman, David Bellinger, Bruce Lanphier. Some of these are still publishing, and of course their teams of collaborators and researchers. If you Google search any one of these names, you'll come up with a list of excellent articles that are very, very good background reading. And I've also shown here a sampling of some recent articles on lower levels of lead exposure and what we've learned. Now, a key finding and a very interesting finding with regard to the effects of these lower levels of lead exposure concerns how the effects are manifested. Unlike higher lead level exposure that can produce clinically observable signs and symptoms such as anemia and gastric problems and lethargy in children, lower levels of lead exposure alter brain function and in turn cause changes in mental function and motor function and behavior that are usually detectable only with the use of neurocognitive tests. In other words, a kid with low-level lead exposure suffering these damaging effects, when a kid walks into the doctor's office, the doctor is not going to see anything or be able to measure anything in a few minutes that lets the doctor know there's something really bad going on. Chronic lower level lead exposure also has the potential to produce long-term damaging effects in some organ systems that are not readily detectable early on. For these reasons, the effects of lower level lead exposure in children have been referred to as silent effects because they're not readily observable upon examination in a doctor's office. Damaging Evidence has also shown that the damage from early exposure to lead continues into adulthood and may make the brain more vulnerable during normal aging. So, interestingly, one of the most influential reports recently regarding child lead exposure in the US was not published in the scientific literature, but instead was done by Reuters reporters M.B. Pell and Joshua Schneier, who did this great series of problems of lead exposure across the US following on the crisis in Flint, Michigan. Their investigative journalism included aggregating census tract and zip code level data and showed that in over 3,000 cities nationwide, child lead exposure was occurring at double the rates observed in Flint, Michigan. And in over 1,100 cities, the rates of children with lead exposure, similar to what happened in Flint, Michigan, was actually 4 times greater. That was a stunning demonstration of this problem, this huge problem that we still face. Around the same time as the Reuters reports, a 2017 report in the journal Pediatrics by Eric Roberts and his team provided compelling evidence that lead exposure in more than 500,000 children every year goes completely undetected. In other words, we're not testing kids. Since their report in 2017, other national and state-based reports have suggested the numbers are likely to be much higher than that. So these data taken together suggested that hundreds of thousands of children across the U.S. continue to be exposed to dangerous levels of lead, and these findings also revealed the inability of our current practices to identify lead-exposed children in the U.S. The obvious first step in managing the problem of child lead exposure has to be accurately and completely identifying lead exposure in kids. So why are we failing to detect children with lead exposure? Well, the answer may be found in the gaps that exist between practice and science. That is, the broad differences between what we do and what we know. Practice is not currently aligned with knowledge. In fact, if you think about it from this perspective, you find that there are 5 critical disconnects between practice and knowledge that are creating barriers to detection and intervention for child lead exposure. These are, first, how children with lead exposure are identified. Second, child monitoring time points. Third, the understood ages of vulnerability. 4, the levels of lead exposure requiring intervention. And 5, the methods that we're using for quantifying lead in child blood samples. So let's start with the first one. We'll go through these in a little more detail. First of all, where children with lead exposure are tested. As early as 1904, Gibson described child lead exposure as a disease of the home. Gibson was referring to a widely used white paint found to be responsible for a massive child lead poisoning crisis in Australia. Since that time, multiple studies have shown that lead concentrations in household dust are one of the strongest predictors of child blood lead level. Home environments within neighborhoods usually share many characteristics, some of those associated with risk of lead exposure. For example, homes in neighborhoods are typically built around the same time with similar materials, often by one or a limited number of contractors, whether these are apartment buildings we're talking about, or multifamily homes, row houses, or single-family homes. So based on current knowledge, the most logical way to test large groups of children is by neighborhood. Currently, however, children are tested for lead exposure as if lead exposure was an individual child's medical illness. That is, on a child-by-child basis and by individual clinicians. Beyond the recommended testing at birth, currently, the possibility of child lead exposure must be addressed in a doctor's office or other child health care facility. A system that requires detection and reporting of child lead exposure on a child-by-child basis only during a visit to a clinic or doctor's office is biased and will necessarily miss huge numbers of children. Children who may not have a pediatrician, children whose parents work and cannot easily take them to a doctor's office, parents without health insurance, or children whose parents simply can't afford the cost of the test will be completely missed. And by the way, these are the most vulnerable, highest risk children. Very importantly, children above current target ages experiencing silent effects in the current system are very unlikely to ever be tested. That is, kids above the age of about 5 or 6. To identify large numbers of children exposed to lead, we need approaches that reach large numbers of highest risk children equitably. So, child monitoring time points. Children are identified as having lead exposure through a blood test. We know that a blood test is a valuable but imperfect surrogate of body lead. What makes blood an imperfect surrogate marker of lead exposure is the highly complex physiology underlying lead absorption, lead accumulation in selected organs, lead distribution, and lead elimination from the body. These are really, really complex fluctuating processes. All other things being equal, blood lead levels are most likely to fluctuate over short periods of time rather than stay the same, particularly when children are exposed to lower level lead exposure. This fluctuation does not equate to a reduction in risk to brain and other organs. It does, however, suggest that children require ongoing monitoring. States vary broadly in their recommendations and requirements for child blood level testing. A majority make recommendations for testing, but do not require testing. Recommendations for testing are very, very different than requiring testing. And most states do not have mechanisms in place to track which children have been tested. It's up to parents and healthcare workers to decide when testing is provided. For example, infants may be offered a test once before 1 or 2 years of age, and perhaps once or twice more, depending on the state they live in and on determination of quote unquote risk based on a questionnaire that parents must complete. And I'll add here that this questionnaire that parents are asked to complete has items on it that can easily be construed as stigmatizing. So for higher risk children, in some states only, additional testing may be provided through Medicaid before the age of 5 or 6, but testing is not likely to be provided again if one test comes back negative. One blood level test is not likely to rule out child exposure to lead, and one blood level test is not adequate for identifying children exposed to lead, particularly at lower levels of chronic exposure. Now, another point in which knowledge does not align with practice concerns ages of vulnerability. If you read the accumulated child clinical literature, ample evidence is provided that children from birth to 12 years of age are vulnerable to the damaging effects of lower level lead exposure. This is not a problem only among infants and toddlers or children under the age of 5 or 6 years. Virtually all states use criteria for child blood level testing that target children below the ages of 5 or 6 years and sometimes include testing only for children between the ages of birth and 2 or 3 years. Depending on a state's guidelines, lead-exposed children over the ages of 2 or 5 will be completely missed. The next point concerns the levels of lead exposure that trigger intervention. As suggested above, since at least the 1990s, it's been broadly accepted that no level of lead exposure is safe for children, but primarily perhaps for the purpose of managing scarce resources. States continue to use different thresholds to determine for which children home mitigation will be provided. While a few states have adopted the newer level of 3.5 micrograms per deciliter, just announced in October 21, many states still use 10 or 20 micrograms per deciliter to determine intervention, even though we know no level of lead exposure is safe for children. Just as importantly, the continued use of these thresholds influences which levels are recorded and monitored. And which levels are recorded and monitored is absolutely critical for understanding the scope of this problem. When you don't record and monitor levels that are below, when you don't record or monitor all levels that are determined by accurate child blood level testing, this leaves us completely without any realistic estimates of the true numbers of children exposed every year. The next point I want to make concerns quantifying lead in child blood samples. And this is perhaps the most important point. The method used for quantifying lead concentration in blood is the critical factor for understanding and managing the current problem that we have. Not all methods of analyzing blood samples are able to precisely detect lead in human blood in the lowest dangerous ranges of exposure. This is particularly true for point-of-care devices. Point-of-care devices are very commonly used as screening tools to determine whether or or not a child should be tested for lead using a venous blood sample. But if the point of care device is not reliable for detecting dangerous lower levels of lead in children's blood, that technology will never be able to help us solve this problem, particularly for lower range blood levels in human blood samples. Inductively coupled plasma mass spectrometry, or ICP-MS, is the gold standard method and should be standard for all child blood level tests. Also note that very precise estimates of dangerous lower level concentrations can be determined with ICP-MS using only 50 micrograms of blood from a capillary finger stick sample. Currently, our current practice is that a blood level test must be based on a venous sample in order to confirm child lead exposure. Instituting the use of ICP-MS technology can allow us to move completely away from having to use venous blood samples to confirm child lead exposure, freeing children from having to go into doctors' offices for venous blood sample draws and allowing us to provide wide-scale screening in trusted neighborhood settings for all high-risk children. Again, currently available point-of-care devices and even some laboratory methods that may be precise at higher levels of lead concentration do not provide valid estimates of lead concentration in blood samples in the lowest ranges of exposure that we now know are damaging. As technology has developed, the costs of ICP-MS analyses have dropped considerably, and this greatly increases the feasibility of wide-scale use of ICP-MS technology for all blood level screening. So I'm going to take a minute here to talk about policy. When we consider policy guidelines that states use, we've mentioned that a few times already, for child blood level monitoring, we see quickly that recommendations and expectations across states vary broadly. Moreover, there are relatively few policies and guidelines in place that specifically address gaps between knowledge and practice. Clearly, the long-term goal here has to be a change in expectations, guidance, and policy. So there have been many advances in the field of public health policy in the last decade. Perhaps one of the most important has been identifying and defining the need and value for evidence-based public health policy models. These models have shown how changes in public health policy must be informed by evidence. More specifically, these models show how policy needs to come from a three-component strategy, shown here, that prioritizes evidence for specific policies suggested. And I'm not going to have time to go into great detail about this, but there's one very, very important underlying detail suggested by these models. And that is that practice must necessarily change before policy can change. In other words, changes in practice must be undertaken before we can see substantial changes in policy. To fix the ongoing problem of child lead exposure, we have to be bold in suggesting what may seem like radical changes to the current system. These changes will then provide the evidence, the data needed to enact changes in policy regarding how we can finally protect children from environmental lead exposure. So there are 6 key elements in the approach that our lab has been developing over the last 15 years, and each of these 6 approaches attempt to align our current practice with current knowledge, and I'll address each of these individually. So first, it's critical to put in place and keep in place a multidisciplinary team that guides local testing programs. We can conclude from our current practices that miss hundreds of thousands of lead-exposed children every year that the problem of child lead exposure will not be solved by our current organization of offices and agencies that completely segregate clinicians who are responsible for testing children from environmental mitigation and public health communication professionals. This approach does not work. New approaches have to bring together professionals from different areas of expertise, employing a synchronized and iterative process of case identification, mitigation, child monitoring, and community organization. The second element has to do with monitoring. As we said before, the physiology of lead exposure suggests that one blood level at 2 or 3 time points, a blood level at 1 or 2 or 3, even 3 time points across several years is insufficient for identifying lead exposure in children. Children, particularly those in underserved neighborhoods, require ongoing monitoring. For several years, our team had set up set this up in local public schools. Situating child blood level testing in trusted neighborhood locations ensures equitable access to blood level testing for all children. We have shown how child blood level monitoring in public schools using fingerstick samples analyzed by ICP-MS can be readily integrated into the normal school day. This approach integrates school personnel into each step of the process while being as unobtrusive as possible. So let me give you some examples of how this can work. We work very closely with school personnel, including the school principal, school nurse, guidance counselors, and PE teachers. We first reach parents and obtain consent on parent-teacher meeting days. Lists of participating children are used to take children in groups of 8 to 10 students from their PE classes, so we're not disrupting the normal learning hours. The kids are brought to the nurse's office, capillary samples are collected, and the kids are returned to their PE classes as a group before the end of the 45-minute session. When results are ready, we meet with parents at schools to provide them with confidential results brochure, explain and discuss the findings. At that point, we can provide extra education and then offer home screening and low-cost mitigation approaches. Now, with regard to routine monitoring, there are 3 critical elements. It must be routine. It must be repeated across the childhood years from birth to 12 years of age, and it must be equitable, that is, unbiased. And we make the process unbiased by using capillary fingerstick samples that don't require kids to go into a doctor's office, and by locating the testing in a trusted neighborhood site. The monitoring program must be planned in a way that allows it to be continued from year to year. It's got to be sustainable. The testing must be repeated throughout the year to capture possible seasonal shifts in lead exposure. 3 times per year is ideal. 2 times a year would be far better than what we're doing now. 3 times a year, when we did it 3 times a year, we would do it at the beginning of September, in December before the kids went on Christmas break, and then in the spring semester. You can also do October, February, May as a spreading it out over the different seasons. The 4th point concerns the type of analysis that's used. ICP-MS analysis, and that's inductively coupled plasma mass spectrometry, ICP-MS, not ICP-OES. It's a different and less precise method. ICP-MS analysis must be used for testing all child blood samples. This is perhaps the most critical detail. You cannot hope to control the problem of child lead exposure if the methods used to test the blood sample do not give precise or reliable results. Moreover, practice that demands a venous blood sample to confirm lead exposure is simply not realistic for the scope of the problem we're facing and unnecessarily biases the testing practice. And as we've said, venous blood samples are not needed if current ICP-MS technology is used for all child capillary samples. If you read back in the literature, you'll see that the biggest concern with capillary samples in the past has been with potential contamination. This concern is easily addressed by a careful multi-step hand cleaning method. For example, in our studies, the children are helped to first wash their hands under running hot water with soap. Their hands are dried with clean paper towels. Then they're given a squirt of a foam hand cleaner that they rub on their hands. And the final step is wiping the hand, and particularly the finger to be lanced, with D-wipes. D-wipes are an industry product used to safely remove metals from the skin. These steps are quick, efficient, and highly effective for ensuring clean fingerstick samples. Using these methods, we are able to complete sample collection from approximately 8 to 10 children per 45-minute classroom session. In a typical elementary school day, there are 6 sessions during which we were able to complete sample collection for approximately 50 children throughout the day. If 250 children in an elementary school need to be tested, those samples can be collected in the span of 1 week. This is a highly feasible approach. Using real-time child blood levels are also very, very important for helping parents help us manage the problem of child lead exposure. Usually we can make the blood levels available to parents within about 3 to 4 weeks, and these are used obviously to identify which children are currently exposed to lead. And thus, us which homes are in need of mitigation. At the time of blood level monitoring, parents are provided with education regarding the simplest methods for reducing child lead exposure. These include, for example, weekly wet mopping and wet dusting, hand washing, leaving shoes at the door, brushing off pets that may bring contaminated lead soil into the home, and educating parents on common local objects that may contain lead. So once a child's identified as having lead exposure, the initial education is reviewed and parents are offered home screening for lead hazard sources. In this way, child blood level monitoring is tightly integrated with the home screening and mitigation. When sources are found in the home, the mitigation team guides parents in simple home mitigation steps. For children with lower dangerous levels of lead exposure, the lead hazards that we've found have typically been isolated sources that are relatively easy to mitigate. So when we talk about home mitigation here, we're not talking about $15,000, $20,000 whole home mitigation where the families have to be moved into a hotel. We're talking about very simple things that the parents can actually undertake safely themselves. For example, one renovated windowsill in a child's bedroom that spread lead-contaminated paint particles into household dust was remediated with lead encapsulating paint in the course of about 2 hours. Or the molding around a limited number of door frames was found in another house, which had been painted with lead paint and was shedding lead into the household dust. We've also found in many homes that we've been into toys and household objects that are contaminated with lead that are simply removed from the home, and the problem is solved. The solutions can be so simple, but they're only possible if kids are being monitored on an ongoing basis so we can see which kids are spiking lead levels, and home screening is done based on those real-time child blood levels. And finally, GIS mapping. So if you imagine this extended over a few years, you can imagine that now you're getting really good data based on ICP-MS analysis from hundreds or thousands of kids, and those blood level values can be mapped using GIS technology. The data is aggregated and shared with the community, and as more and more children are tested, you can track the trends in the blood levels and then determine future monitoring needs. If this is done in the way that we're describing, you can bring blood levels down in whole neighborhoods, and maybe that would inform then how monitoring goes forward, right? Or in those neighborhoods where child blood levels keep cropping up at different times of the year, perhaps the monitoring program would stay in place. So this brings us back to the model I showed you at the very beginning of the talk. This is our interdisciplinary neighborhood-based approach for monitoring child lead exposure. It includes fingerstick monitoring, perhaps in public schools. That's how we've done it. But of course, if there are other trusted neighborhood locations that can be used, such as church basements, churches, we've done monitoring on Sunday mornings in some local churches as well. You could also be doing this in Head Start centers. You could be doing this in recreation centers. Any place where people are already congregating and where the neighborhood trusts the location can be a good site. And then, of course, we get the blood levels from the kids, and those real-time child blood levels are returned to the parents, and the parents are given education and guidance with regard to home screening and home monitoring. And finally, community organization is absolutely critical to give the results to the neighborhood, teach them about this problem, and enlist their help in managing the most likely sources of child lead exposure. Okay, so let's just do a quick summary then of key points. In the US today, child lead exposure is still a major child public health problem and unresolved child health disparity. Current approaches are missing hundreds of thousands of children every year. New neighborhood level interdisciplinary strategies are needed to provide routine, unbiased blood level monitoring to large numbers of children at risk using capillary blood samples and ICP-MS analysis. Real-time child blood levels should be used to guide home screening and low-cost parent-initiated home mitigation. Blood levels are aggregated over time with GIS mapping, monitored and used to track progress and plan ongoing monitoring at the neighborhood level. And finally, community organization, knowledge transfer, and monitoring are continual. All right, well, I want to thank you all for listening. I hope that's been interesting for you, and I hope it's given you some ideas about how to manage this problem we have with lead exposure in U.S. children. Thank you.
Dr. Sobin, thank you so much for that presentation. We do have questions that have come in, so I'm going to go ahead and ask those for you now. First question that I have is the level now reduced to 3.5 ppm?
Yes, it is. And it's not ppm, it's micrograms per deciliter. So the 3.5 refers to the level that's identified in children's blood samples. And the standard way of measuring that in the US is micrograms per deciliter. 3.5 was recommended in October 2021 by the CDC. So it came down from 5, which had been recommended in 2012.
Great, thank you. Isn't lead more dangerous in youngest brains? So won't this monitoring miss the youngest of 0 to 3 or 0 to 5-year-old?
Yeah, I'm so glad you asked that. So what we had the kids do when we were doing this in the public schools, any moms that had the littlest kids from infants up to 3 or 4 before they were in preschool, we would have them bring them to the school on special days. Thank you for asking that. I meant to mention that. So we don't miss those kids. We tell the moms to bring them in on mornings when we are there, especially to do infants. And I'm really glad you raised that as well, because for the infants, the kids, we use finger stick, but of course for the infants, if they're really, really tiny, you use heel stick. And we've even had some moms bring in kids after they get the blood level test at the hospital, because the hospital, as many of you know, some hospitals will do infant blood level testing at birth or in those first few visits back to the hospital for well baby visits, but they never return the results to the mom. And we've had plenty of parents tell us that, and they'll bring their little ones to us for testing because they're not getting the results from the hospital that are taking the samples.
Great, thank you. I've got another, it's a 2-part or maybe a 3-part question. It's should all children be routinely tested for blood lead levels? What test type do you recommend? And if not by blood level, or is the point that monitoring needs to be ongoing?
Yes. Okay. So what we're suggesting is that all kids need to be testing. We need a return to universal testing. There used to be a thing in the US called universal testing in a lot of states, and that meant every child was tested. That was when the problem was higher levels of lead exposure. So what we're suggesting is we have to have a return to universal testing. Every child is tested, just like every child gets a hearing test at the public school. Every child gets routine testing for a number of different things in the public schools, and we want to include blood level testing in that. And you use finger stick samples. So I made reference to capillary draws, and that's completely different from a venous blood sample. Currently, in order to say that a kid has lead exposure, the kid may go through one of those screening tests that's not reliable at lower levels of lead exposure. And if the kid tests positive on that unreliable screening test, then the kid will be sent to a doctor's office. Well, a lot of times there's a gap between a kid getting that screening test and even making it to a doctor's office. I made that point a few times. When the kid gets to the doctor's office, the doctor is required to do a venous sample blood draw, take the blood from the arm. That's a very big deal for little kids. And a lot of kids refuse that, and a lot of parents refuse it, depending on the culture of the parents especially. And so what we're saying is you have to do capillary finger stick samples. So capillary refers to the little glass capillary tube that's used to collect the sample from the tip of the finger. And what's been really a boon for us in making this even more doable than it was in the beginning when we started this work is that now so many people in the homes are testing their own blood samples for glucose. So now we get kids in and we explain that we're going to do the finger stick sample that their parents approved, that, gave consent for them to do this. And we show them the finger stick. They say, oh, grandma does that every morning. So that really helps us out that that's going on in so many homes now across the nation. So you do the finger stick sample, you just poke the end of their finger, you have a glass capillary, you collect 50 microliters of blood into the glass capillary, and you plunge that into a collection tube, a microvial, and then that gets sent to a laboratory for ICP-MS analysis. So that's the method that we're recommending. And when you use capillary finger stick samples, you do not have to do a venous blood draw. This can be transformative for the whole, the whole need to test hundreds and hundreds of kids every year.
Thank you for clarifying that, because there was another question that actually led venous type. And so I think you covered that. The question was blood tests, especially venous, can be highly traumatic for
Right.
children. Have you seen or do you foresee any kind of pushback from parents conducting these type of testing 3 times yearly until the age of 12?
Yeah, so the point is that we don't use venous samples. Venous samples would not ever be used again for this. It's not necessary. And I know that's very hard for people to wrap their heads around because that's been so much the standard for so long. But again, I would encourage anybody who has interest or curiosity about this, go back in the literature and read those original statements by the CDC and the discussions of capillary versus venous samples. And what you'll find is that transition to venous samples, when it was decided venous blood samples had to be used to confer lead exposure, forced this procedure to go into doctors' offices. And that's where we're hitting all the bias, because the highest risk kids are not going to get into doctors' offices. And as you importantly point out, venous samples for kids, they'll run away. They don't want to get it. And the parent, a lot of times the parents don't want their child to have it, and they don't think it's important enough for them to have it. So this is a huge stumbling block right now in getting kids tested for lead exposure. If we can just transition to all capillary samples where kids do not have to have venous samples anymore, and you analyze capillary samples by ICP-MS, we'll have very precise results from very small samples of blood.
Thank you. Another question coming in is, do you see a use for community health workers, promotoras, promotoros, in community testing process?
Yes, absolutely. Promotoras can be very, very important for many aspects of this model that we're suggesting. And by the way, you know, when you're doing finger stick samples, that is considered a safe and no risk procedure by the FDA and the CDC, which means anybody can be trained to do a capillary blood draw. And promotoras could certainly be some of the people drawing blood samples from kids, because it's a very, it does take practice. We practice on each other at the lab. But as I said, it's not a high risk procedure. It's not a procedure where you even have to worry really about infection or anything like that. It's a simple finger stick with a child-sized lancet.
Thank you. Other than Head Start sites, is testing done at daycares, preschool programs, etc.?
Yes, exactly. So the example that I gave is the program that we set up in local elementary schools, because there's many elementary schools that are close to our university, and also we have wonderful principals in El Paso, Texas, and we just had such a great time working with them, and they welcomed us into the public schools, the elementary schools, and like I said, we figured out how we would do it so we would not disrupt any of the learning in the classrooms, and how to get the littlest ones into the school on special days for testing. But you could certainly set up exactly this kind of approach in Head Start Center and daycare centers and YMCAs, YWCAs. Again, you just want to be where the kids already are. That's the most important thing. And to be able to integrate the blood level monitoring into a normal day's activities is really, really important. So it's not such a big deal, because right now, this child by child basis, one child going into one doctor's office, you know, it's just not, it's never going to manage the problem that we have.
Another question is, do you test pregnant mothers of school-age children?
We have, and we do offer that to the moms, but I do want to say that we've done all this work as a research program. So we are not medical doctors, and we make that very clear to moms. And in fact, when we do our blood level testing of children and we see levels that we know a doctor would make a recommendation to the state on, we tell the mom, you need to go to the doctor and show him this result and get a confirmatory test so you have access to all the services currently available. We want to do that because right now the state will not act on the basis of blood levels from a research program. So we're trying to bridge that gap. But certainly we have found lots of kids, some with relatively high levels of lead exposure, where the parents never had any, it never crossed the parents' mind the kid had lead exposure.
Thank you. Another question we have is, what was the elevated rate in these testing programs in the schools?
So elevated, yeah. So it depended on the year. right? So it wasn't until 2012 when the level came down to 5. So when we started this work in 2006, 2007, the level was 10. So we would advise parents that their child had lead exposure below the current, then current level of 10. We would advise them and we would give them all these ways that they could improve, that they could potentially manage the problem of lead in household dust through some of those techniques that I mentioned. Then in 2012, as we were testing kids in our more recent batches of testing procedures, we used 5. We would use 5, but in our study, HUD study that we were funded to do, when a child had a level as low as 2.5 or 3, we would go into the home and offer screening and monitoring. And we actually have results showing that we bring the levels down by going into the home. And you know what's really interesting is that even in homes where there were 1 or 2 homes where we were not able to identify anything in the home that could explain why this child had a blood level of, say, 3 or 4. And we trained the parents, we educated the parents on wet dusting and wet mopping, brushing off animals, not letting animals bring in soil from the outside, taking shoes off, hand washing. I talked about those different, very simple, low-tech methods, and it would bring down child blood levels. So, part of it, that education is widely available to parents, but you have to get to parents individually and as a community, and you have to convince them of the importance of this, that, you can't just dismiss, a child blood level of 4. And when you have a child's blood level and they see a level, it has a different impact than if you just go into homes and educate without child blood levels.
Where or how we get these reliable CAP tests, and what is the cost, and is it covered by insurance? One particular participant is a nurse, has stated that Venus is so difficult to get parents to do.
Exactly.
And have the reliable CAP test, and do you have information on how to obtain it or make it available?
Yeah, really good questions. So ICP-MS is the gold standard. That's the only analytic method that should be used for child blood samples, especially capillary samples, of course. So ICP-MS is available at all of the standard laboratories like Quest, and I'm not thinking of some of the other ones, but Quest is the big one here in El Paso. Standard laboratories all have ICP-MS. The problem is the standard for-profit laboratories charge an arm and a leg for those analyses. They will charge as much as $100, $120 per sample, which is very, very expensive. And obviously we have limited resources for this problem. So in our research, we found we've worked with two different laboratories now, and actually 3 different laboratories for ICP-MS. And it's available in a lot of different settings. Most universities, definitely universities that have medical schools, will have ICP-MS capability, and they may have multiple machines, multiple ICP-MS analytic labs that are set up. So universities are a great resource. And another resource are public health departments. I know our local public health department has an ICP-MS device. Let's see, where else can you go? You can find different laboratories. When we were working with individual laboratories, research laboratories, our first laboratory was up at NMSU, Tanner Schaub's laboratory. They did a lot of samples for us. They were great. And they were able to do this at cost for us, at first for about $32 a sample. And then eventually the costs went up as time went on. We worked with them for a long time to about $37, $38 a sample. And in addition to that cost for the ICP-MS analysis per sample cost, you have the cost of the capillary tubes, which is minimal. Those are very inexpensive. And you have the collection vials, which are like little microvials that you collect the 50 microliters into. And the microvials actually have an attached capillary. So if you get the right kind, you don't have to have separate glass capillary tubes. And the cost of those is less than, I think it's like about 50 cents a piece for the little microvials. They might be a little bit more now. And we use the lithium treated ones to prevent blood coagulation, which is very, very important for ICP-MS, that your blood doesn't coagulate in the tube. Yeah, and that's about it. So if you can find somebody to help you do this at cost, which should be possible through a Department of Public Health or through local medical school laboratories and research laboratories, that can be a solution. Did I hit all the points of that question, Marema?
Yes, thank you so much. I know that there was a lot of questions, so I was trying to make sure that I didn't lose one there. Folks, we are at the top of the hour. Thank you all so much for attending this presentation. Dr. Sobin, thank you so much. If there
You're
are
welcome.
questions that come through, folks, please feel free to send me an email and I will make sure that I get that to Dr. Sobin.
Marema,
Thank
can
you,
I
Dr.
ask, can I just say one more thing? Yeah, so our laboratory welcomes questions and we want to share what we've been doing. We have an extensive manual that covers all the different steps in the model that I showed you, and we are happy to share that with anybody who wants to start making use of these newer practices. So please reach out. We're here and we would love to hear from you.
Great. Thank you so much.
Bye-bye,
Thank you,
everyone.
Dr. Sobin. Thank you. Wonderful talk.